Answer Part 2.
Convection!
Convection occurs in liquids and gases. Let's see it in action. We took a beaker of water, some potassium permanganate to dye the liquid, and guided it to the bottom of the beaker. Well, eventually.
It's going down, it's going down, it's going down, it's going down.
We then started to heat the liquid, but just at one corner of the beaker. The hot liquid began to rise towards the surface. Cold liquid was drawn in to replace it. On reaching the surface, the hot liquid began to cool. This caused it to sink before it was drawn in to be heated again. A convection current had been formed. This eventually transferred heat from the flame throughout the whole volume of water in the beaker.
Ooh, convection!
But why does this happen? Oh, great one.
Well, as the liquid is heated, the particles in the liquid gain energy and move further apart. The liquid expands, it becomes less dense and starts to rise to the surface. New liquid is drawn in to take its place. Meanwhile, the hot liquid at the surface begins to cool. The particles get close together. In other words, the liquid contracts, becomes more dense and sinks towards the bottom. A convection current is formed and the liquid is drawn towards the flame where the whole process begins again. There it goes, becomes less dense and rises. Convection, who cares? Convection, who cares? You should. It affects the whole planet. And this living room. All sorts of things. Convection is responsible for the powerful currents in our oceans. These are dangerous for swimmers and drive the Earth's climate. There are also huge convection currents in the magma underneath the Earth's crust. These are responsible for the movement of the Earth's tectonic plates, which lead to earthquakes and volcanoes. Which reminds me, lava lamps work using convection too. Look at the hot wax blobs rising as they become less dense.